Hello all, very good morning. Thanks for joining the session. Let me share my screen. Okay, so yesterday we have seen the divide and then conquer policy or divide and then conquer architecture. In the divide and then conquer architecture, we have created the two applications called categories and then modules. And then we have created the third application called vShopify app modules. And these three applications we were built using a parent application called vShopify app. And thus we got the vShopify app modules created with a var file. That var contains all the jars of the categories module and then the products module. Perfect. So now what we can do, so what we have observed, actually we have observed still there is a limitation. Even though we followed the divide and then conquer architecture, still we have the limitations, right? So even though this divide and conquer architecture, even though the divide and then conquer architecture is giving us the flexibility of the separating the application modules as a separate separate smaller applications. Even though this divide and then conquer architecture technique is giving us the flexibility of the separating the application modules, giving us the flexibility of the separating the application modules as a smaller applications which can be built as an independent applications, but building packaging as a still packaging all these modules as a single archive and using the shared DB. So this again having the monolithic application characteristics. So to further resolve the monolithic limitations in 2014 let me just go to this microservices material. Just let me double check. Yes, principles. Yes, in 2012, not 14, in 2012, the microservices were evolved. Okay, so to further resolve the monolithic limitations, in 2012, microservices were evolved in a global architects summit in Venice. by the Martin Flower. So further to resolve the monolithic application limitations, in 2012, microservices were evolved in a global architecture summit conducted in Venice. Conducted by the Martin Flower. What happened? Martin Flower is the guy. In 2011, he invited all the architects across the globe for a summit in the Venice. So that is the workshop of software architects. It happened in May 2011. So in that architects workshop, Martin Flower asked a question to all the architects. So what are all the problems you are facing in your application, and what are all the solutions that you are applying to resolve those problems, is what the question asked by him. Then most of the architects were replied like, they are using the application with the divide and then conquer architecture to loosely couple the application modules, and they are building all these modules as a single archive. Like just yesterday, as I have shown, right? So just shown yesterday. So what we did actually, the main application is divided into external applications. The modules are divided into an external applications, but these are all the modules again conquered together, right? So most of the architects were replied that they are using the divide and then conquer policy, but they are facing a problem of the single archive. They are building it as a single archive. So again, it is behaving as a monolithic applications. So in 2012, Martin Flower and other architects were, in 2011, this summit happened, isn't it? In 2011, in May, this summit happened. So Martin Flower asked all the architects, okay, so we are now using the divide and then conquer architecture, and that is still having the monolithic characteristics. So how do we make these divide and then conquer applications are there, right? If you can closely observe, divide and then conquer architecture is very close to microservices architecture. In fact, in 2012, 2013, we worked for a client called Gemalto. So there we used this divide and then conquer architecture. But at that moment, we don't know as those are the microservices. Really. And we even have used these applications, we even have run as a independent applications. Now what is happening here? These modules are conquered in this vShopify app now. But at that moment, we divided the applications and then ran on JT server. That is the microservices architecture. It is not new. It is not invented like our Java or any other technologies. It is just like evolved. The existing problems were resolved, and then it is evolved actually. So if we can closely observe, if we apply one nature to our concurrent, divide and then concurrent, if we apply one nature, then it becomes microservice. Because in divide and conquer architecture, what we are doing, we are separating the modules into independently buildable applications. They are independently built. See this, they have the capability of the independent building. Now what we need to do, we need to just furnish these divide and then conquer architecture, then it will be becoming microservices architecture. What is that? Self-executable capability. If we provide the self-executable capability, then those will becomes the perfect microservices. What is self-executable capability? Okay, now when we build this vShopify app, this vShopify app is building these products and then categories, isn't it? The products and then categories, we are getting the jar files, isn't it? Those jar files are not self-executable. That means, let me go and then run this architecture one more time, meaning build this architecture, application architecture one more time. Just paste here. Quickly, let us build it. Just quickly, let us build it. This vShopify application. CMD, and let me first do the MVN install. Quickly, let me do the MVN install because already seems to be the application is in clean state. So let me apply the MVN install. Okay, now build order, reactor build order, categories module, products module, vShopify app, and then vShopify app modules. Like this, these are building. Let them build. Perfect. Build happened successfully. Now let's go back. Go to this categories module. Go to target. It got the jar file. But when we execute this jar file, Java hyphen space categories, it is not able to execute. So when we are making it as an executable, it becomes a microservice. That's it. Because if you closely observe all the microservices characteristics that these products and then categories applications will have, that means the divide and then conquer architecture is dividing the modules as a separately buildable, packageable applications. But those packages are not self-executable. If you made them as a self-executable, that's it. Those becomes a microservices. Because what are microservices? What are microservices? Microservices are autonomous, self-executable, independently deployable, small applications, right? Now let us run the theory here. Okay. Okay. So divide, and if you can understand correctly, divide and then conquer application architecture. Architecture is having the independently packageable independently packageable applications, independently packageable modules. Okay, let me just write the theory, which is very important for us to easily understand. So divide and then conquer application architecture modules. Divide and then conquer application architecture modules are dividing in such a way that they are independently packageable. They are the independently packageable, but these packages are not self-executable. If we further furnish these modules that is independent packageable applications, we further furnish these modules that is independent packageable applications as an executable, then they become microservices because of microservices are autonomous, self-executable, autonomous, independently build and deployable, self-executable, smaller applications, tiny applications. So because of microservices are autonomous, independently build and deployable, self-executable, smaller applications. So if you can see this definition, the independent modules now, the modules of the Shopify application, we were created as an independent applications, right? So first of all, these applications are also the modules now become an independent applications, right, inside the divide and then conquer architecture. So these are all smaller applications which contains only the module specific files inside it. And these are autonomous because every application contains its own JRE system library, its own package and then build mechanism, and it contains its own source code within this module only. So that is the reason it is autonomous and independently build and deployable. So independently buildable, but not deployable. And these are not self-executable. So if we make them as independently buildable, independently deployable, and then self-executable, if we make them these two, then those becomes what? Microservices, right? So if we make the divide and then conquer application architecture modules into a independently deployable and then self-executable, then those becomes the microservices, right? So now let us see the microservices, further microservices, about further microservices. So microservices are an architectural style used by many organizations to develop more physically separated modular applications to achieve the high degree of agility, meaning lightweight, speed of delivery, and scalability. Microservices are not invented, rather evaluated. So these are not invented like Java. These are evaluated on top of the divide and then conquer application architecture. So how the microservices are evolved? Let us see how the microservices were evolved. So many organizations such as Netflix, Amazon, and eBay successfully used the divide and then conquer technique to functionally partition the monolithic application into smaller modules, atomic units, each performing a single function. Exactly what we also have done. Na? So this Shopify application, we were converted into a small atomic units, which contains exactly one functionality. So we converted the huge application into smaller applications where each and every application is performing a single responsible task. For example, categories contains only the categories code, products contains only the products code. That means already eBay, Amazon, Netflix, they successfully used the divide and then conquer technique, right? So, but these organizations solved a number of issues when they are using this divide and then conquer application with their monolithic application. So when they started migrating these monolithic applications into divide and then conquer applications, they have solved a number of issues in the monolithic applications. So following the success of these organizations, many of the organizations started adopting this as a common pattern to refactor their monolithic application. So by looking into success of these organizations, Many other companies also started following this, breaking down the monolithic application into divide and then conquer architecture. So later evangelists termed this pattern as a microservices architecture. So the divide and then conquer applications are now further furnished and then termed as the microservices architecture by adhering few principles and characteristics. Very, very important. So later, evangelists termed this pattern as the microservices architecture by adhering few principles and characteristics on the divide and then conquer technique. That is exactly what I'm conveying. So whatever the modules that we have created as a separate applications using divide and then conquer application architecture, if we further furnish these as a independent deployable and then self-executable, that's it. This becomes the microservices. That is the reason microservices are not invented, they are just evolved, right? So if we apply the few principles and then characteristics on the divide and then conquer technique, then it becomes a microservices. However, microservices are an architectural style for building the applications as a set of smaller business components that are autonomous, self-contained, loosely coupled, independently deployable, self-executable. I think these are also we have to write. So microservices are an architectural style. Microservices are an architectural style, an architectural style. We'll discuss about this architectural style in our RESTful services discussion. So these are all an architectural style with the autonomous and self-contained and loosely coupled, independently build, deployable, smaller applications, right? So these are all what the microservices characteristics: autonomous, self-contained, loosely coupled, independently deployable, and then self-executable. Smaller applications are called as the microservices. Okay, let us see the below diagram to understand the microservices. So this is a huge monolithic application which contains the presentation layer, business layer, database layer. Presentation layer is using by the 3 modules, business layer is using by the 3 modules, database is also using by the 3 modules. Now, if we divide this architecture, meaning if we vertically, let me just copy this, and this is the architecture, right? Let me just paste it here. Actual size, let us go too big. Control V, resize. So this is the architecture, right? That is the monolithic architecture, right? Now, how the microservices will, how the microservices came, from this? Carefully observe. If we draw if we vertically divide this, let me just use one pen. Yes, crash pad. Draw images or URLs here. Let me cancel. What I'm trying to explaining is this architecture. If we vertically slices down, so if we vertically slice down, then it becomes a microservice. So how I can vertically slice down is what I'm thinking about. Yes, see this? If we again vertically slice down this module B, see this? And then if we again vertically slice down this module C, Now see, module A presentation layer, module A business layer, module A database, and this is module A application. Similarly, module B, this is module B application, contains the module B presentation layer, business layer, module B database. Now this is what module C presentation layer, business layer, and then database layer. Now what when we vertically slice this down, then we got the microservices, meaning this outer box you consider as an application which contains the only source code related to the module A, and also module A having its own database. Similarly, module B and then module C. Correct? So this is how we got the microservices now. So when we vertically slice down the huge monolithic application, we got the microservices. Now it is time to understand the microservices characteristics. See, this is what exactly we got. Module A, microservices, module A database, presentation layer, module A presentation layer, module A business layer, module A database layer. Now this becomes one microservice. Module B presentation layer, module B business layer, module B database layer. This becomes one microservice. And similarly, module C becomes one microservice. So when we vertically slice down the monolithic architecture, then we got the microservices. But we have to make sure it will be adhered to few characteristics and then principles. So what are those characteristics and principles we will see. But before doing that, let us understand this microservices with the honeycomb analogy. In our villages we might have seen the honeycombs, right? Honeybees will construct these honeycombs. Correct? Carefully observe, please, because this is very important theory to understand the microservices. What are they? So if you can see the honeycomb analogy, so honeybees will create the honeycomb by constructing a small wax cells. These hexagonal cells are called as the wax cells. So honeybees will construct a small wax cells. Few honeybees, meaning the honeybees will be divided into small groups. Or maybe sometimes each and every honeybee will construct one wax cell. But whatever it is, honeybees are usually grouped into a few honeybees are grouped into one group, and then they will responsible for constructing some portion of the honeycomb. They will do that actually usually. So honeybees, while constructing this wax cell, they use any material. At that moment, what they got, they will use that material to construct these wax cells. Maybe they will use grass, maybe they will use wires, maybe they will use even stones, maybe they will use anything, whatever available at that moment for them. Using that material, they will prepare this wax cells. Guys, let me plug in my charger. Just give me a moment. Okay, perfect. Now, this honeycomb analogy is talking about few points actually. Honeybees are divided into a smaller groups. Point number one. Honeybees will construct these smaller wax cells. Point two. Point three. If all the honeybees will construct the wax cells like this, finally a huge fabric structure will be framed. That is called as honeycomb. Point 3. Point 4. While constructing these wax cells, honeycombs will use the material whatever is available at that moment and then construct these wax cells. So let us write these points. Let us understand the honeycomb analogy. Honeycomb analogy. In honeycomb, why I'm again typing here? This is the kind of a lab guide letter we will use to easily understand, furthermore easily understand the microservices. However, in honeycomb analogy, okay, honeycomb analogy can be understood as point number 1. Honeybees will divide into smaller groups and responsible for construction of the honey wax cells. Honey wax cells. Point number 1. Point number 2 is what? Point number 1. Point number 2 is what? Honeybees group as many honeybees groups will construct the wax cells. Slowly it will be grown as a complex fabric structure called honeycomb. Point 3. Honeybees, while constructing the wax cells, they used the whatever the material they got at that moment. Like they might use grass, stones, whites, etc. Next, if we hit the honeycomb with a huge stone, then the particular portion of the honeycomb only get damaged. Yeah, if we hit the honeycomb with a huge stone, then the particular portion of the honeycomb where the stone hit is only get damaged, isn't it? But not the entire honeycomb. So these only damaged wax cells were being repaired by the honeybees to again reconstruct, reconstruct the fabric structure. So why we understood this honeycomb analogy? If you carefully observe one thing in this honeycomb analogy, like how the honeycomb, how the honeybees are divided into small groups. Similarly, like how the honeycombs are divided into small groups. Similarly, the developers also will be divided into small groups for developing the microservices. So let me just take a picture of honeycomb. Let me just visit this. Yes, so seems to be this is a perfect picture for us. So honeycomb are constructing, honeybees are constructing the wax cells. A perfect suitable diagram for us. Just let me read this. Perfect. Huh? Now see these small cells, wax cells, these are. Honeybees will divide into smaller groups. Like how the honeybees will be divided into smaller groups, developers also divided into smaller groups. Like two or three developers will be as one group for developing the products categories, and two or three developers are divided into developing the shopping cart and then delivery services. Maybe one or two developers are divided into one group, whereas they are working on the integrations. Like that, the developers will be divided into smaller groups and responsible for construction of the microservices, right? Like how the honeycombs are doing the job. Similarly, you also, we also, even myself also will do the same job in microservices development, right? Next, as many honeybees groups will construct the wax cells. Like 2 to 3 developers are framing into one service or two more services development, right? So like that, if all the groups will start development, it will becomes, you know, all the microservices, a huge microservices development will be completed. So like how the honeybees groups will construct the wax cell slowly, it will be grown as a complex fabric structure called honeycomb. Similarly, when we develop our application as a microservices slowly, at one point of time, it becomes a lot of microservices, and that lot of microservices will constitute our application, right? Will constitutes our application. Next, honeybee will, while constructing the wax cell, they used the whatever the material they got. Similarly, the developers, while working on creating the microservices, developing the microservices, no matter what the technology the developer know, he can use his technology and then prepare the microservice. For example, as you know, we have the, let me run our application quickly. This is our application. Let me run quickly. So we have the customers module, we have the orders module, we have the products module, and categories module, and then delivery module, security module, all these modules, isn't it? So security module can be implemented using Go language. Orders module can be implemented using the, you know, Python, and then the customers module can be implemented as a separate microservices using the Java, and then the products microservice can be implemented separately using a technology called PHP. No matter whatever the technology, but we have to build the microservices, which is satisfying or following the microservices principles and then characteristics. like how the honeybees are constructing the wax cell with the whatever the material they got at that moment. The developers also can create the microservices or develop the microservices with whatever the technology they know. That is called polyglot architecture. That is called polyglot architecture. So microservices will support the polyglot architecture. However, we'll discuss about it going forward while discussing the microservices characteristics and then principles. Now, if we hit the honeycomb with a huge stone, then the particular portion of the honeycomb will only get damaged. Similarly, if any issue will come to this microservices architecture, let me showcase you microservices architecture with orders and products. Yes, microservices architecture. Let me showcase you this microservices architecture. So from this is our reference site for referring the microservices patterns. Yes, so the book is also published by Chris Richardson, Microservices Patterns. The same book we can refer. Of course, I'm following this site and then the book also. However, what I would like to showcase you is the monolithic architecture. So just to scroll down, here there will be one one application. Okay, otherwise let us go here and then see. Yeah, if you can see this, there is a passenger management, billing, driver, web UI, payments, notification, trip management, right? So let us visit this site. So here are the microservices. Now what I'm saying is, if any microservices will be damaged, or if the few of the microservices, let us say trip management and then the notification got damaged, then only these particular microservices get damaged and then these get repaired later on time. But still the other microservices can run as is without any problem. The only thing is what maybe the data related to the trip management notification might not get in another microservices, but the other microservices will still be able to run without any issues. So like how the honeycomb is damaged to a particular portion, similarly if any issues or any exceptions will come and then damage only particular part of the microservices, that should not affect the other parts of the microservices for sure, because the microservices are independently executable autonomous applications, tiny applications. So the application to application communication, microservice to microservice communication is happening using the REST APIs. So if this trip management is down, no matter, no problem, this only will go down. The data of trip management might not be used or get in another microservice, but the driver management, payments, passenger web UIs, still they will be continue. Still they will be work. And these only damaged wax cells were being repaired by the honeybees. Similarly, only the errored issued microservices can be fixed by the group of developers who constructed or who developed these microservices, right? So this is about the microservices understanding how the microservices architecture to be with a simple honeycomb analogy, right? So let us see then the microservices principles and then the characteristics. Very, very, very important. If you are a microservices developer, how to convert or how to create or how to migrate a monolithic application to microservices, meaning you must have to know the microservices principles. Those are, many members will feel like, if you divide the application into a smaller applications like this, if we divide the applications into smaller applications like this, those are microservices. No, never. These divided applications may or may not be the microservices unless we applied the microservices principles and then characteristics on these modules, which are okay actually, which are working as an independent applications, which are developed as an independent tiny applications, but as they are tiny applications, as they are independently buildable, packageable, we can't say these are microservices, because we have to make sure these are adhered to the principles of the microservices principles and then characteristics, right? So principles of microservices and then principles of characteristics. So these principles of microservices and then characteristics, let us discuss tomorrow. Okay, so that's all for today. Any questions for me? Don't miss tomorrow's session, because very important. Principles of microservices is very important, because while we are discussing this principle, we'll discuss about the solid design pattern. Damn sure question, in damn sure interview question, 100% interview question in your interviews, solid design pattern. So while we are discussing about the single responsibility pattern, we'll discuss about this solid design pattern. Don't miss the coming up sessions. However, that's all from my side for today, folks. Any questions for me?
So one small doubt.
Yeah.
This the common core with respect to all the microservices, it has to be put into different microservices, is it? For example, it could be in util functions, or it could be in common code which is getting shared between the microservices. How are we going to keep it as a separate one?
Okay, so basically, all the common code, usually without microservices, all the common code will put into one application, and that application will be refer as a dependency in another applications, so that that application components we can get here. See this? Let us say common components, let us build as a one separate application.
Okay.
That application let us refer wherever we want as a dependency.
Okay.
So we will be able to use those components.
That will be in terms of jar only, right?
Jar only.
Jar only. Okay.
In fact, we will do the same in our triangular pattern, and all in our microservices patterns. We will do the same pattern. We'll follow, especially in CQRS, event-driven microservices, Saga and then CQRS will follow the same pattern. Okay.
So, okay, sir. In that case, like having it as a dependency with respect to SJAR, whether like still it holds good of microservices, or it is a monolithic one?
No, it is microservice, because microservices having the bounded context principle. That bounded context principle is suggesting us to do like that. Okay. I will explain. Going forward, I'll explain bounded context principle. So that principle is suggesting us to do like that. So we can be feel free to go and do, because we are not making the functionality as a dependency. Rather, we are making the domains as a dependency, not functionality.
Function, okay. Domains, okay.
Yes.
Okay.
Sir, one thing I want to know that is not related to microservices, but I want to know from Spring Boot. So one annotation I have read that is the annotation as an attribute. So why we use have we covered annotation or not?
Sorry, can you please repeat that question, please?
So
I'm so sorry.
I want to know about the annotations as an attribute in Spring Boot that is there. So why we use, sir, that I'm not aware, sir.
Okay. Session attribute, right?
Yes,
okay.
Yes, sir.
What we will do is, for your question, let me showcase this switch to workspace microservices. So while we are building this strategy, meaning this triangular pattern, let us use the same. So session attribute meaning what? If any data will be inside the session, that data we can take inside the application using the session attribute. I will showcase. We have implemented it in the 7 a.m. batch. So, but I have not taken the annotation. We will take it while we are implementing this triangular pattern. So the data that is putting in the session, just let me showcase you that. Go here. Our service. Go here. Customer service. Okay, my bad. Let me just this is okay, one service. Now what we'll do is, let me quickly showcase you the triangular pattern. Sorry, C colon. Carefully observe what we are doing. Open this workspace. Let me open the 7 a.m. workspace quickly, because we have done the same, and of course we will also do here also while building the triangular pattern. So session attributes we will use. Let it open. I will showcase just in a moment of time. Let it open. Okay, triangular pattern is the way, like, you know, we will step by step convert the monolithic application into microservices, because converting all the monolithic application into microservices in a single shot is not possible, in fact impossible also. So that is the reason what we will do is step by step we will convert. If you can see here, there is a V Shopify triangular we have written. What is doing is, this triangle is talking to the customer service. This triangular facade is a filter talking to this customer service, getting the data. That data we are putting inside the session. If you can see HTTP request dot set attribute, of course I am here putting into the request, but even we can put it into a session. Assume we put the session. So now the number of records per page we want in somewhere. Let's say I want in this platform. So in the platform, where I want in the platform, I want the data to be paint, or I want the data to be taken in our customer module. Assume just customer controller, I want to take the data. So the data is where now? The data is in the session. So what I can do now, I can use the session attribute annotation to take the data in our any of the methods here. Got it?
Okay, get me.
Yes.
So top of this method, we can use that.
We can use, correct. We can use. Okay. So at the rate, actually, we can use it here itself at the rate session attribute, not on the method. Yes, session attribute, not on the method. My bad. Okay, it is we can use here. So for example, let us say number of records. So whatever the number of records we are getting there, int number of, that's it. So we can have this value in this method, because this is already have been set in the session by some other method or some other functionality.
Yes.
Okay. Yeah.
Okay, got it. Thank you so much. Thank you so much.
Yeah.
Hello.
Yeah.
Hello,
yes,
sir.
Yes.
I have a small question. Every application we can write integration test, and what about integration test of why we can write? Can you explain?
Correctly. Every application, why do we write the integration test cases?
Yes.
So unit test cases are testing a particular piece of the code. That means usually we will write layer and then the repository layer or DAO layer, right? So we will apply the unit testing on the particular repository layer or maybe on the service layer. So when we test the service, automatically this service is also test the repository, because service will use the repository or DAO. Similarly, in order to test this is only testing a particular piece of code. For example, see if you can see save customer, update customer. This is just testing the methods. But to test the complete functionality, like how from the UI we will test by logging into the application, creating the customer from the form and all, right? So to do that kind of testing, we have to test the controllers actually. So if we test the controllers, then complete integration can be tested. That means if we test the controller methods, controller will be tested, service will be tested, and then the DAO or repository will be tested. So complete integrated components got tested. That is called as the integration testing.
Okay.
But
I means whole application we can test the integration test.
Correct.
And only JUnit test is only one of the method is
Correct.
we can test, right?
Correct. Particular piece of the method we can test, or a smaller methods we can test using the unit test cases. But the complete application functionalities we can test using the integration testing.
Okay, every application we can write integration test, right?
Yes, obviously, being developers, we will spend our time in unit testing only.
Okay.
Personally, my suggestion, meaning as an architect, whatever the applications I was architected, I don't entertain the integration test cases to be run, because integration testing will be done by the performance engineers or the QA engineers. They will already generate the test cases reports, integration test cases reports they will generate. Again, putting the developers time in writing the integration test cases is, at least my opinion, may not be correct, but it is good idea also to have the test cases, because while we are doing the CI/CD pipeline, we can easily generate the reports of these integration test cases.
Okay, why? Because in my project it's working on integration test, so that's why
Correct.
I'm asking you.
Correct. That is true.
Okay, thank you, sir.
Okay. Yeah.
Sir, last question, sir. While developing the microservices, as you told, each microservice may develop with the different technologies.
Exactly.
One is with Java, one is with PHP, something.
Exactly.
So, end of the day, as per developer view, these many technologies are burden, or we are gathering these many technologies is somewhat burden compared to monolithic applications, right?
I got your point actually. Here, what we are developing independently executable applications. Okay.
Yes.
Assume some resource is good at Go language, some resource good at .NET, some resource good at Python, some resource good at Java. So if I want to, for example, some module typically have to implement it using the Python. I can't put the Java developer to learn the Python. Rather, what I can do, I can go and then hire the Python developer and then ask him to develop only that particular piece. It is not burdening to the Java developers, because we should not force the Java developers to learn the Python and then write it. No, it is time waste. Rather, what I can do, that particular service, I can go ahead and then work with the Python developer especially and then make it work. That is what the polyglot architecture.
Got. But what is the actually industry standard, sir? Suppose generally you see number of microservices projects. They are using the different languages, or suppose
sometimes few modules sometimes should have to go with the different technologies. Obviously, few modules. For example, few modules in the sense, let me take Go language is super fast compared to our Spring Boot or microservices. For example, orders microservices there, which is very high microservice, meaning high volume microservice. That kind of microservice we can implement it lightweight technologies like Go language or Erlang languages. So based on situation, so that flexibility we have in the architecture. So industry also following the same standards.
Okay, thank you.
Yeah. Okay, folks, I have to take the AWS session now. I'm stopping my screen share. See you tomorrow at the same time. Thank you so much.
Thank you, sir.
Thank you.